Hey guys, we're going to do stats homework 8.2. Now let's look at what the assignment was. So the homework assignment starts on question 29 and does a bunch of the odds, so make sure you check the assignment. And then it ends here at 55 through 58. So I've actually added in some places to kind of show my work. So question number 55 states, a Gallup poll found that only 28% of American adults expect to inherit money or valuable possessions from a relative. The poll's margin of error was 3%, so it looked like this, if that makes sense. And they gave this at a 95% confidence level. What does this really mean? So we know that what that means is that if we created a bunch of confidence intervals, right? If we created many of them, each with their own little point estimate, slightly different, then wherever the truth lies, then 95% of them would capture the true population. So which one kind of summarizes that? And again, you might be thinking, well, how do you remember this? We want to reference back with our notes, right? So we know that, let's see, in our Hershey Kisses, they don't talk about it, but in our previous activity, let's see, where are our notes? Yeah. If we take many samples and calculate a confidence interval for each, then about that percent will capture the true parameter, right? So when we look at our homework, it says the first one, A, the poll uses a method that will get an answer within 3% of the truth about 95% of the time, right? And that's what we're essentially saying here. We're saying that this confidence interval would capture the truth about 95% of the time. This interval, right? So we like A, but let's go ahead and eliminate the other ones. The percent of all adults who expect to inherit must be, we never like must. I can't remember the last time I picked something that said must. And so we noticed that when we did multiple samples, we noticed that we don't know for sure if it's this interval. All that we know is when we create this interval, we get a lot of variation in and around whatever the true proportion is. And essentially, there's nothing special about these values. It's just that's a broad enough interval in order to capture 95%. The truth 95% of the time. So looking at C, if the Gallup takes another poll, then these results would be that. And it's like, no, in fact, we would actually think they'd be slightly different if we took another poll. So there's a 95% chance that the percent of all adults who expect an inheritance is between, no, that's not like a chance of rain. That's not what we're talking about. We're talking about actually producing these intervals, and 95% of the time we capture it, which means 5% of the time we don't capture it. So E, Gallup can be 95% confident that between 25 and 31% of the samples, no, see how that's swapping, of the samples expect an inheritance. No. That would tell us only 25% of people in the sample, and that's not what that is either. Okay, so we've decided on A. Now let's look at 56. It says, refer to exercise 55, okay? Suppose the Gallup wants to cut the margin of error in half. Very interesting. Now, we did this on our test question from the last chapter, so it's going to have the same effect this chapter as well. They just keep kind of asking the same question in a slightly different way. So if you wanted to cut the margin of error in half from 3 percentage points to 1.5, how would they adjust their sample size? So we said with Hillary Clinton, right, if she doesn't like this, then we can ask more people in order to reduce this. So if we wanted to bring this much narrower, then we'd really have to drive up n. So how are these values affected? So when we look at our choices, we know that the point estimate is equal to whatever information we get, plus or minus the margin of error. And if we want to make this margin of error smaller, right, we have to dig into, well, what makes up the margin of error? So if it's a 95% margin of error, then this would be 1.96, and that wouldn't change. So the only way to change the margin of error and do what they've asked us, cut the margin of error in half, we have to look at the margin of error itself. And again, it's the z star times the standard error of the sample proportion, right? So we did a little bit of this today. Our margin of error is equal to the z star times the quantity, the square root of the quantity p hat, 1 minus p hat, all over n. So notice here, if I want to cut the margin of error in half, I can divide both sides by 2, right? And that's still an equal sign. The left is still equal to the right. And now we can do a little bit of algebra magic. If I want my margin of error cut in half, then z star is still the same, but I could rewrite the problem over the square root of 4, right? That would be the same thing. Now, if I continue to think about that, this I could write z star, right? The top is p hat 1 minus p hat. The bottom is the square root of 4 times the square root of n. And again, last but not least, I could think of this is the square root of p hat 1 minus p hat all over 4n. So in order for the margin of error to be cut in half, I need n, my new n, or what will fall on the bottom of my equation, has to be 4 times bigger. So my answer is I'm going to need to multiply the sample size by 4 in order for the margin of error to be cut in half. Okay? Nice. Question 57. Most people can roll their tongue, but many can't. We investigated this in our class. It says the ability to roll a tongue is genetic. Suppose we're interested in determining the proportion who can roll their tongue. So that's our parameter. We test a simple random sample of 400 students and find that 317 of them can roll their tongue. The margin of error for 95% confidence interval for the true proportion is closest to what? Okay, so there's a couple ways to do this, but again, what did we learn and what do our notes say? We said our point estimate plus or minus our margin of error. So here our point estimate is our p hat, right? So 317 over 400. Now they kept it at 95, so I can continue to use this value for my z star. And then I have b hat, 1 minus b hat, all over 2. So what is my p hat? So let's do a quick calculation here on my phone. 317 divided by 400. All right, so it's 0.7925. 0.7925, and then what would be 1 minus that? 0.2075 all over n, and it looks like I talked to 400 students, right? So when I multiply those and divide by 400, all right, and then I take the square root, I get, right, so I guess I did all that. I get the standard error is that. Okay, so I'm going to multiply. That would be 68% confident. So I'm going to multiply to make it 95%. Multiply by 1.96. And I get 0.7925 plus or minus 0.0397. Cool. So what would this be if I rounded it? There we go. We have our answer, D. All right, last question, 58. A newspaper reporter asks an SRS of 100 residents for their opinion of the mayor's performance. Using the result from the sample, the confidence interval for the proportion of all residents in the city who approve the mayor's job is that. So this is working backwards. Okay, so once again, we need this, right? We need our formula, point estimate plus or minus margin of error. What is the point estimate? Well, it's some number over 100 because we talked to 100. But notice we know the interval here. So this goes back to our first class, right? These formulas here. So if I know the margin of error, right? Or if I know the interval, notice I can find the point estimate. It's just the number in the middle. So I can use these two formulas to find out the point estimate. So if I have an interval, so we'll start over, right? If I have an interval, then my point estimate is just somewhere smack dab in the middle of that. So to find out, you add the 2 and divide by 2, the midpoint formula. All right, and that gives you 0.63. So the point estimate is 0.63, and then what is the margin of error? So again, once I get my point estimate, I'm adding or subtracting. So I have, it's got to be my upper bound or my upper interval minus my point estimate. So that would be 0.695 minus 0.63 would tell me my margin of error. Also, my lower interval, let's see, I'm thinking too hard. Let me do this first one here. 0.695. Yeah, okay, so my margin of error is 0.065. I could have also done it the other way around where I had my point estimate and I subtract my lower interval. And it still should give you the same answer. So if you have a point estimate of 0.63 and you subtract your lower interval, 0.565, we get the same number. All right, so we know a few things now. We know the point estimate, and we know the margin of error, and we know N. So we're trying to solve, in a weird way, we're trying to actually solve for Z star, because that's actually what tells us our, like for instance, if we solve for Z star and we get 1.96, we know it's the answer is D. Our confidence interval is D. So let's play that out. So it's P hat, 1 minus P hat, all over N, take the square root of the whole thing. And we actually know that this margin of error is equal to 0.065. So what is P hat? Well, we solved for it. Our point estimate, 0.63, times 1 minus 0.63, all over N, which we were given in the problem, it's 100. So let's crunch some numbers. Divide by 100, then take the square root, And I get 0.04828 times z star equals 0.065. Okay, so if we want to figure out what z star is, we divide this on both sides. I'm going to turn it upside down and multiply it by 0.065. Okay, so for z star, I get 1.346. Okay, so I could look at my table, but I could also, I found out in previous classes, right, we can calculate this, right? We can calculate this value by, let's see, when did we do that? Right? We calculated it by hand, right? So, and we did this because of how things would work out here. A 95% interval would give me 5% left over, or 2.5% on either side. So using that kind of same premise, we can do that here. Now I'm just going to erase some of this stuff from another problem just so I have a little bit more room here. So let's see. I have a value where in the middle is my point estimate, and z to the left, 1.346, and z to the right, we're trying to figure out creates how much area under this curve, okay? Well, using just a regular old table A, we can figure out at this z value, what's the area to the left, and that's going to tell us that amount. So let's go to table A. Here, if I go to AP Central, I can get my formula sheet. And my number is 1.346. So if I go to negative 1.346, negative 1.346, I guess would round to 1.35, I get 0.0885. Okay. So this is 0.0885, which means since it's symmetrical, this is 0.0885, which means we can figure out what the red is. That'd be 1 minus 0.0885 minus another 0.0885, and we can solve for what is the area under the curve. And I get 82.3, which would round to my answer A. Very interesting, right? Now, we could also double check this for reasonableness. So we got a z star value of 1.346. Okay, so if we go back to our tables and go to this table B, 1.346. Notice in our table, let's take a quick look at this. If I look at my formula sheet, here's all my critical values. Right? And 1.3, it's somewhere between here. You see what I'm saying? And so 82% has a z star value of 1.346, which makes sense. That answer definitely makes sense. And it's quite a bit, 1.3 is quite a bit closer to 1.28 than it is 1.6. So again, this is the answer that makes sense. And it's possible you didn't have to kind of do this last step. You could just kind of extrapolate or approximate based on what the table says. Nice job, guys.